I brought some stuff to show you and maybe make a bit more sense of this. Let's see. And I know I had issues. Just wait 1 second. So cool. You won't want to miss this. Alan, do you mind turning it back on, the light? I think it's better when the light is on. Do you see 0.000? Can you see that? Yeah, I know it's hard to see. I can't fix it. I don't know why. Is this pretty precise? If it's 0.000 kilograms, you bet it's precise. It's a kitchen scale. So let's put something on there. Can you see that? 0.539. Okay. What's the precision of this thing? If I asked you, what's the precision of it? What would you write down? 0.001. What's the uncertainty? 0.00005. You're right. So this can go up by 0.001 of a kilogram at a time. So sticky notes, let's see what that does. Oh, it went up by 2. Let me try this again. It should only go up by 1. No, doesn't like that. Okay. Oh yeah. Okay, see what's happening there? The fluctuation. There's a rounding happening in the background. It doesn't know where to round. It's that uncertainty that that it doesn't know what to do with. Okay, so technically, if this is 0.38, then that gets me to 40. Anyways, this device will be very, very precise. And if you went through the units, I have different units. I can do this in pounds and ounces. Right? I could do this in fluid ounces, which I wouldn't want. Milliliters, that's if you're like weighing something liquid. Grams, 540 grams. So it can do a bunch of things and it's pretty precise. So what about this? Let's go over to, anybody know what this is called? Voltmeter, right? You measure electricity, like current and amperage. How many volts are in a battery, like a AA? Anybody know? Approximately. Let's see. It says it right on here. Can you see that? 1.5. Yeah. Do you think there'll be actually 1.5 volts in here? You think it's going to be more or less? Less? Well, let's see. So I'm going to grab my voltmeter, and I can get more precise as I want. But let's just go with this. This is to the nearest volt. So I'm going to go positive here, negative there. How many volts? 2. It's 1.5. Well, how come it's 2, right? Let's make it a little bit more precise. So I'm going to add a decimal there. So now it's to the nearest tenth. So it's 1.6. Why did it show me 2 earlier? It was rounding. It was the uncertainty. It was actually like to the nearest volt plus or minus half a volt, right? So that's what's happening. If we do even more precise, it's actually 1.62. So, and why is it more than 1.5? Well, it's tolerance, right? When they make these things, it's mass produced, so there will always be a little bit of leeway. So your electronics, they are made in such a way that it could be, the voltage could be higher, so you won't fry your watch or whatever you put this into, right? They got to make sure they allow for that. So even though you might have a 12 volt electronic device, you're probably putting in more than 12 volts when you're putting in these batteries, right? Because if you have a bunch of these, you get up to 12 volts. There's this one here. This one. Anybody know how many? Oh, 9 volts. Amazon, right? It's an old one, so I don't think this one will have 9 anymore. It's already been used up. So let's see. 7.24. So it's supposed to be 9, but it's past its lifetime. So anyways, that's that. What I'm about to do, you do not do at home, okay? You're not doing this at home. Just for illustration. This is plugged into the outlet there. I'll be fine. I've done this many times. Okay? I know what I'm doing, but you don't do this at home. How many volts are in your outlet? Anybody know? What? 110 is technically what we're aiming for. Do you think it's going to be 110? Now, if you use a voltmeter, there's something called DC current, direct current, that's battery. But we have alternating current in our homes. So I'm going to go there. And so, are you ready for this? Don't. Yeah, I know. He wanted to show us how this works. That's a good headline. 115. We were aiming for 110, but 114, 115. Why is that doing that? You know where this electricity is coming from? A hydroelectric dam, right? Hydro, the water is going through these turbines and they're spinning really, really fast. So it's always fluctuating a little bit. It's traveling through wires and all of that is like fluctuating. But it is actually the uncertainty that's making it go up and down. Because this is now only good to the nearest volt. But I can go even more precise. This is 113.8. So that's why I was going between 113 and 114 because it had to round. So that's what we're doing when we're measuring. At some point we round, right? At some point we say this is all we can measure. Even though there's more to measure, we can only go this far, okay? So I just thought, give you a real life example of what we're doing. It's actually happening. It's just that we don't think of it, right? Okay. Those that wanted to go to the bathroom, if you give me 13 minutes, 14, I can teach what I need to teach and then you'll be good to go. All right? Okay. So grab your books and go to 93. 93. And I highlighted a whole bunch of stuff. If you missed this, you're going to want to go back and catch up on notes. Can you wait 10 minutes or no? Can you? If you can't, you go, right? Like I'm not being cruel here. Yeah, if you need to go, you need to go. I'm not being cruel. I don't want you to miss things. Okay, Alan, could you turn off the lights again, please? Okay. Tolerance is what? Just to make sure. Tolerance is the measurement variation that will be allowed. Everything that we consume has some kind of tolerance. Your thermostat in your house, when you set it to, what is it set to for most of you? Maybe you don't even know, but I have mine set to like 22 degrees Celsius at home. That's pretty warm. My wife likes it nice and warm, so we don't fight over it, right? You just give in. But do you think the temperature is always 22? Nope. It actually, your thermostat is programmed that it will probably go down to 21 and then it will kick in. Will it stop heating at 22? It will actually go up a little bit, probably to 22 and a half, 23, and then it will turn off. What is that? That's tolerance. Like it accepts a little bit of a leeway, but you don't think of it. But it will allow it. Otherwise, things just wouldn't work. Nothing is perfect, right? So it's the range of sizes that are acceptable, the range of acceptable values. Like this is tolerance in many different ways, over and over, okay? So there are 4 ways that we're going to state our tolerance. It's like this, min and max, like stacked like this. The next one is nominal, plus or minus half the tolerance. So you state it like this, and we were able to read out our information. These 4 you should always be able to take from this. always. Then we had one where you had our value here, and then it goes -0 plus 2 degrees. We were able to also fill in these 4. And then this one here is technically your max. How do you know this is your max? By the way, let's say you forget everything about this on Monday. Can you go any higher based on this? You can't, like it's +0, so this is your max. Okay, that's how we found out. We tried adding 0 and we ended up with 0.5, right? The min you get by subtracting here. Tolerance is always max minus min, so we subtracted that. But for all of these 3 formats, watch this. All 3, the first numbers always are nominal. That should be the first thing you fill in. If you get that, then you're almost there already. Now I'm going to give you one last one to copy down here. This is a bit of a not included in the book, but I'm going to ask you to write this down. If you have this page filled in, you basically have everything you need to work out tolerances. So just copy this, okay? 45.05 plus 0.02 centimeters minus 0.03. And we're going to extract max, min, and I'm just doing this in this order, but it doesn't need to be done in this order. So let's see, I know it's Friday, last period of the day, but what's the first one I could fill in based on this? The first one, it's highlighted in all of the ones before. Nominal. Let's grab our nominal and just say, hey, I don't know, I forgot everything else, but I remember Mr. Dirksen told me, grab that first number and place it in there for nominal. The next, I would say you should try to get your min and max out of that. How do we get our max? You guessed it, 45.05 plus, just add that number up there. And our minimum, notice that they're different, right? They're different, but don't let that throw you off. You just go with it. We're just going to go ahead and subtract it. And so from this, the top number will be 45, and use a calculator if you're not sure. I don't like you getting these wrong just because you didn't want to use a calculator, okay? And then mine, because sometimes it's going to be hard to just do this in your head. Some of the numbers are tricky, so I don't want you to get it wrong just because of that. So you got your min and your max, sorry, max and your min. And how do we get our tolerance again? Max minus min, right? It's subtracting. So I'm going to actually write this down so you don't forget. So you take your max. It shouldn't be negative. Don't get a negative. And something went wrong. And that is 0.05 of a centimeter. Okay. So this isn't like an oddball question because it doesn't have the 0, but it shouldn't throw you off. Get your nominal. I'm going to highlight that just to stay consistent with what we did before. Go ahead. And now I'm going to give you a tolerance worksheet. Did you know that at crosswalks for pedestrians, like at a light, you know these little pads they put down, like with the yellow stubs or whatever? Did you know that some of them actually have a sensor on there that weighs you? like not accurately, like they're not like, how heavy is this person? It's just like, oh, there's weight on this. Next cycle, I'm gonna give you a green, I'm gonna give you a go signal, or it's gonna speed up the light cycle so that you get to cross a bit sooner than if you hadn't been standing on it. It's also a slip prevention thing, I know that, but there's a bit of a, go ahead, there's a bit of a tolerance there. So if a car drives on it or if a motorcycle goes on it, it would probably not trigger it because it would sense something is wrong, right? Something is wrong. It's not a person that's trying to cross the road there. Anyway, so this tolerance sheet is not in your booklets. I just made that actually this morning. So I'm going to give you that because it's very good practice. And I'll just give you a little bit of a preview. So this is all you do for today. If you want to be ready for the test next week, I'm getting you ready. So there's some precision and uncertainty again. And notice that it asks you to measure it. So you have to have measurement plus or minus the uncertainty you figured out earlier. And so I have a various images, all kind of stuff, some explaining to do. And in the back, this is what we did today, this stuff. And I ask you to fill in those 4 things that you need to fill in. Okay, so that's what you're doing today. I know you're tired. I know you're not feeling like it, but do it because then we're done. Okay, before the break, we're done with this.